Hey everybody, so last time we looked at the idea of there being two different classes. We thought you could either have a dog or a cat. And so we could think about our model to predict for this as a probability making machine, where at first we get the probability of it being a cat. And so reversely, that's basically the probability of it being a dog as well. If we have a 70% guarantee it's a cat, well, that's basically a 30% chance that it's a dog. And so we would guess cat because it's closer to cat. But if it was less than 0.5, we'd say, oh, that's actually closer to a dog. We'd assume that it's a dog. Now, how do we actually get this line here? Okay, this curve right here is this weird function, and we don't know how to get that. Well, I'm going to just spare you from a lot of the math and say that if we create the function y hat, and that's what we denote by our prediction, which is actually just a probability, okay? So remember, this isn't our final answer. This is just between 0 and 1, and then after we'd actually take a guess of either 0 or 1. This is just what our model by itself is going to produce for now. And so y hat, if we make that 1 over 1 plus e to the negative, guess what? A line, okay? If we do simple linear regression for now, we can extend this to more betas, but we could do beta naught plus beta 1x, and if you don't know what this e thing is here, that's totally okay. E is roughly equal to 2.71. It's just a constant, so if you're not used to e, just replace it with 2.7 and it's going to be exactly the same thing. So here, 1 over 1 plus e to the negative, a regression line, okay? So that's basically saying if we were fitting a line, if we had some data and we fit a line that looked something like that, basically we turned this into this thing over here. We do this by just putting it through this function over here. And that allows us to go from this type of data where we have zeros and ones, and then we actually use this function as our prediction. We try to learn these parameters. So we try to learn beta naught and beta 1. Given our training data, x and the y's, we fit that just like we would before using gradient descent, okay? So the loss function about how close our model is, well, we're gonna have to think about what this is. It's gonna be a little bit of a more complicated discussion, except in general, we can think about it as, if our model's up here, if our model predicted here, and the answer was actually up here, well, we could think about that as some sort of error right there. And it's not too big of an error, but it's a little bit of an error because it was definitely a 1 rather than just it was technically predicted to be a 1 by us because it was like a 0.7. Maybe that's what we would think that it is, except we really should have given an answer that's super high up here. We should have given it as close to possible as 1 because it turned out to be a 1. That would be our loss function that would help us in learning what this is. And again, if this was our prediction, if we predicted the same value here, but the actual answer was down here, if it was actually a dog, well, that should be a huge error. And so we have a lot of adjusting our parameters to do. Now again, we want to learn beta naught and beta 1. Our goal is to try and find these parameters to make the right curve, okay? We're trying to draw the right type of curve over here, this white line, this whole thing right here. The data is the yellows and the reds. We're trying to fit that the best by drawing the best curve. And so it's going to get kind of messy here, and I'm going to draw it bigger and bigger so it's actually possible. Basically, we could draw some sort of curve that maybe looked something like this, or maybe we could draw some sort of other green curve in here. I'll make that even bigger. It's going to look weird, but something maybe like this. Okay, this type of curve. And that's going to be our probability graph. And it's all some function. It's still something like this, except that looked hilarious with the big arrow. It all looks the same type of curve, except it's different based off of the values of beta naught and beta 1. Okay, we're trying to learn those to draw the right curve. That's what's dictating these changes in the graph here. And so, well, before what we had for beta naught and beta 1, it was just this line down here. So beta naught was wherever it crossed the y-axis, so maybe beta naught turned out to be this value for the data. Okay, it was dependent on the data, so maybe the data was something like this. And so we got beta naught is this value right here, and then beta 1 is whatever the slope is going up. Now, it's kind of sort of similar with logistic regression here with these weird curves, and I'm going to go way back so that it gets rid of all of those ugly drawings I had there. You can actually go ahead and just play around with desmos.com/calculator. It's a graphing calculator that'll show you if you add sliders and you change beta naught and beta 1, then you can bump it around and see how this changes the graph, how it does this, how it maybe moves it over here. It turns out it's as simple as Beta naught represents the location. So basically, it's not going to change the shape of this thing at all. The shape is always going to be this. Beta 1 represents the shape of this thing. And then beta naught, what that does is basically, if we were to decrease beta naught from whatever it was before, we could change it, decrease it a little bit, and then maybe that changed it like this, okay? It's supposed to be the exact same shape of the curve, except it's moved into a different location. So that's a less value of beta naught, and a higher value of beta naught from what it would be this. But we prefer the value of beta naught that's associated with the red one because that's what fits the data better. We also want to learn what beta 1 is, and that basically represents the shape of this thing. So that would be not where it's moving like this, okay? It's not just moving the same shape left to right. Well, that's what beta naught does. What beta 1 does is basically the shape, and so that is the steepness or the direction of this curve, and so it looks something maybe like that is a different value of beta 1, and that is a bigger value than it is for this one. It's a steeper curve up like this, and an even bigger value, if something maybe in green, is something like this. Okay, that's also a possible different value for beta 1. We need to learn the right one for the data. If we learn the right values of beta naught and beta 1, as always, we'll do this through gradient descent, and next time we'll look at the loss function, how we can measure the error and say, oh, actually, no, I want to tune this beta naught, I want to tune this a little bit to the left, or this beta 1, I want to change this actually a little more up to a curve that's up like that. We'll look at how to do that by measuring the error in our function, and it's kind of weird, so don't worry if you don't understand that too much, but I'll see you in the next video for sure.